Thanks, Max, for joining us. This is the Wildfire Cluster meeting in September 12th. And we've invited Max Jones to come to us and brief us on his ESIP Lab project, which I have interest in as well. This browser-based visualization of satellite-derived active fire data. So I know Max has to leave a little bit earlier today, so I'm going to throw the floor over to you, Max, so you can give us a briefing on your ESIP Lab project. We're really looking forward to it. In the ESIP Wildfire Cluster, we're talking a lot about identifying trusted data and how that data can be used and shared so more people can get better situational awareness, get their eyes on what's happening with wildfires, and share that information within their communities. So, Max, thanks so much for joining us, and floor is yours.
Thanks, Dave. So as you mentioned, I'll be talking about browser-based visualization of satellite-derived active fire data. This is work I did with my team last summer at Carbon Plan, including Raphael, Oriana, Grayson, and Kata. I'm now a cloud engineer at Development Seed and still focused on bringing most data to be more accessible through cloud optimization and browser-based visualization. And as you mentioned, this is an ESIP Lab sponsored project. So to start out with, Carbon Plan is a nonprofit that focuses on improving the transparency and scientific integrity of climate solutions with open data and tools. And one component of that is analyzing the efficacy of carbon offsets. So carbon offsets are a mechanism by which carbon emitters can purchase credits that will offset their emissions and allow them to continue emitting while offsets are ideally reduced elsewhere in the world. And one of the mechanisms by which offsets work is through carbon forest offset projects. In this scenario, usually some component of forest management or other strategy will aim to reduce the or store more carbon or reduce emissions in forest settings, and these credits can then be sold to carbon emitters. Unfortunately, forests are highly vulnerable to various diseases, fires, etc., which means they can be lost. And in Carbon Plan's work on this topic, they have been monitoring the intersection between forest offset projects and fires. So this is an example of an image from NASA Earth Observatory of the 2021 bootleg fire, which unfortunately caused many losses, including to forest offset projects. In order to track these losses, Carbon Plan built a public web-based monitoring tool shown here. So you can see geographic outlines here for different US states, just to give some geographic context. And there's also two different polygon layers. The gray polygon layer shows the boundary of these forest offset projects. And the red polygon layer shows the boundaries of fires from the National Interagency Fire Center, or NIFC. And from this, you can see, for example, the bootleg fire burned many different sections of forest offset projects, which actually made these go insolvent. While this is really useful for a retrospective analysis of forest offset project losses, it offered some limited utility for projecting or monitoring into the future. Because while NIFC data is really valuable and useful and that it does have ground-based validation, that also makes it less updated less frequently. So you have to wait a period of time until the perimeters are updated for active fires. Through the ESIP Lab Award, we were able to add a new layer for active data or active fires from satellite data. So this is the live updating monitoring dashboard for 2024. And you can see there are the same gray and red polygons for forest offset projects and NIFC fire perimeters, respectively. And we also have a new vector layer in orange, which shows thermal anomalies from satellite data. So this can represent actively burning fires. from this, you can see which offset projects may not be currently burning, but are threatened in the future. For example, here you can see there's currently no intersection between this forest offset project, but there are active fire happening in close proximity. And in this tool, you can also see a live tracking of the total project area burned for the current fire season. So now that we've seen what came out of this project, I'm going to go into a little bit of detail about how we got there and how it was enabled by both data products and also by ESIP through their funding. So we are building the active fire data from NASA FIRMS, or the Fire Information for Research Management System. This provides a UI for visualizing thermal anomalies from multiple satellites. And it also provides an API for getting that data as KML or CSV files. This is really useful for many different needs. For us in browser-based visualization, we required a cloud optimized format of this data, of the firm's data. And so we built through our ESIP Lab project a open source MIT licensed data pipeline in Python to cloud optimize the MODIS and VIIRS data from NASA FIRMS. So you can view the repository here, Carbon Plan Forest Offsets Fires, to look at our pipeline or even build off of it yourself. This pipeline queries the NASA FIRMS API for VIIRS and MODIS data. It then filters the data to exclude low confidence pixels. We also subset the data to just the United States because that is the region that we have project polygons for. And so it cuts down a little bit on the storage space required. And then we generate two different cloud optimized data formats. First, GeoParquet, which is a great format for analyzing point or vector data on the cloud, and then also vector tiles, which provides opportunities for performant web rendering, as we showed in our dashboard monitoring tool. We do this using GitHub Actions for continuous integration. So rather than manually running the pipeline to cloud optimize the latest data set, GitHub Actions will do this on a 6-hourly basis. So at any point in the monitoring tool, you'll be seeing data that's for roughly, that's for anywhere from near real time to 6 hours ago up to 3 days ago. We also built, as part of our ESIP Lab award, a tutorial showing how we built this pipeline and how you could modify it to fit your own needs in both analysis and visualization. This QR code, I think this presentation will be shared afterwards, brings you to this tutorial online. One component of the ESIP Labs Award is really focusing a lot on lessons learned. So we originally proposed using XAR for this use case because we've had a lot of benefits from using XAR as a cloud optimized data set in the past. XAR really excels at the analysis and visualization of n-dimensional raster data sets. The MODIS data itself is a point-based data set. And so we found in this case that vector tiles worked a lot better because you didn't lose information through the rasterization process. And we were also able to highlight both fire intensity at coarse zoom levels by mapping the opacity to the thermal anomaly intensity. And also we could see clearly the active fire fronts at the high zoom levels because, again, you didn't lose that information during the rasterization process. So once again, here's the product from the ESIP Lab, which includes the new layer on our monitoring tool, as well as the open source pipeline and our tutorial. So I'd encourage you to take a look at this yourself. Unfortunately, this is once again a bad fire season, and there's a lot of data present in the web tool currently in September of 2024. Using this tool, the Carbon Plan team has continued to engage with journalists and also conduct scientific analyses on the intersection between project offset or forest offset projects and active fires. So in carbonplan.org/blog, you can see some of Grayson's most recent work on the consequences towards carbon crediting programs. There's a lot of active, current, and future work that could be done based on the products from the ESIP Lab Award. As I mentioned, there's active monitoring for the 2024 fire season, along with active engagement with journalists. And also, there's, I think, a real need for additional cloud optimized fire data to enable more use cases like this. As I mentioned, we used only the medium and high confidence pixels, and we subset it to the United States. But there's a lot more sophisticated approaches to evaluating the confidence of how thermal anomalies relate to fires that could be done, and also having additional variables that come off the satellites included in the cloud optimized data set would really extend its value for both scientists and journalists. So I think that this is really a stepping stone for future work with the NASA firms and other thermal anomaly data sets. And I want to thank ESIP Lab for this opportunity. I also want to thank my former colleagues at Carbon Plan for all of their great work. If you want to get in touch with Carbon Plan, you can reach out through hello@carbonplan.org. If you want to get in touch with me, I'm on the ESIP Slack, or my email is max@developmentseed.org. Thanks, Dave, again, for offering this chance to talk about the ESIP Lab Award.
This is great, Max. Thanks so much. I had a question for you about interacting with journalists. What kind of activity is happening there, and are you proactively contacting journalists to let them know that this platform exists so they can monitor it, or what are you doing there?
Well, my information is a bit out of date since I switched positions to development seed in July, but from what I expect, the editorial lead at Carbon Plan, whose name is Maggie Korth, is managing the relationship with journalists. When she notices something that's happening that might be relevant to a specific journalist, she could reach out. And also, there's many journalists who would get in touch without prompting through either existing relationships or just emailing hello@Carbon Plan.
Oh, that sounds good. And you said that you sort of ping the NASA firms data every 6 hours?
The API, yeah.
The API. So have you tried like more frequently, or is that how frequently that data set updates, or do you just did you do a little trial and error to see what works best?
Um, we decided to do 6 hours actually mostly for historical reasons. It's the same frequency that we were updating the NIFC data. There's some convenience to having all your layers have the same schedule for updating. There's no need to fetch NIFC more frequently given its more sporadic update rate. I expect, or like, that NASA firm's API could handle more frequent queries. We also want to be kind of good, like, citizens of data users and not overwhelm them when we thought that 6 hours was sufficient for our use case.
Yeah,
Like, for
I have
example,
with the
probably we're looking at the
firm.
tool every 6 hours. So
Yeah, yeah. I know we dive into NASA firms data through their KML services, which means it's basically live. So whenever, they update the KML files, their network KMLs, so they update in the mapping environment too. But this is a great interface. I'll have to dive into it. And I see Megan on the in the chat says, I totally read a CNN article that referenced Carbon Plan at some point in the last few months. So
I mean, it's both like wonderful and also sad because it means that there's like losses happening actively because of viruses when the news cycle kind of picks up on the
I'm
tool.
just wondering if you could just take another minute, Max, and just describe again the areas of forest that are identified as, you kind of want to protect them as carbon offsets. Why is it concerning if a wildfire enters one of those boundaries?
Yeah, I can speak to this at a high level. For any technical details, I'd encourage people to get in touch with Grayson Badgley, who leads the carbon offset programs at Carbon Plan. But essentially, so for example, they might buy some credits that are due to a forest manager cutting down their trees every 30 years rather than every 15, because in those extra 15 years, the trees will store more carbon. And so that theoretically offsets the carbon that is emitted elsewhere. However, if the trees burn down after 5 years of growth, it's actually like there's not only no benefits, but there's also less carbon storage than what you expected in the like no change scenario in which the trees were able to grow for 15 years before being cut down. So it negates any theoretical additional carbon sequestration, and it's also just bad for the carbon budget in general, because now those trees, the carbon's been emitted into the atmosphere rather than being stored as biomass.